This is John Habager again with JL Filming. This is Group 26 of the Growing Degree Day Monitor. Some measurements of the device is still open for our demo day. So one of the first couple things I want to go around is that everything's getting powered as we had originally specified. So as you can see, it's a very sunny day out right now. We've got our voltmeter. I don't know how well that's going to come up in the shot. I'll see if I can set that on my lap. Can you see that, camera guy?
Yes, I can.
Okay. So first things first, nice sunny day, let's look at the solar panel. So as you see, we're at 5.73 volts on the solar panel. So if we look at what we are looking at in terms of our batteries, let me go over to our battery connector. Batteries currently have 5.12. Do you see that?
Yes.
Okay, so and our V reference, if we check V reference can get selected. V reference is 3.3 volts, which is what we have specified in our specification. So since it's sunny and the batteries are at a lower voltage than the solar is going to be in the process of charging the batteries at this point. Let's see if I can maneuver. There we go. So as we said, this panel's, if you want to hold that. So I'm going to look at our charge enable signal on our probe. So as you see, the micro is delivering a charge enable signal of 3.3 volts. So we have currently opened the switch and we are charging the batteries right now. Now as we wait for the batteries to charge, we're going to look at well, they probably won't charge that quickly, so we'll just look at a couple other features power-wise. We have our ground and air temperature sensors working right now. So it's about in our 70s right now. The LM35s record in degrees Celsius. So I'm going to currently look at our air temperature sensor. If I put the probe on the air temperature sensor, what's that currently reading? 300 millivolts. It's 300 millivolts, so it's saying it's around 30 degrees Celsius. It's a bit high, but pretty consistent. On our MSP 430, we do have deltas to adjust the temperature from the A to D readings. And then if we look at the ground temperature sensor, which it's currently next to the ground, so G-temp sense and ground, what's that reading?
It's about 239.
239. So the ground is about 6 degrees Celsius cooler according to these temperature sensors. Now as you look on our model, which is hard to see because of the sun, we currently have this light just permanently displaying. We don't have the full micro operational, just the charging and power circuits. This is an LED that indicates we're receiving battery power to most of the circuit. This is the LED that indicates that we have our specified regulator voltage. So just a quick other kind of overview of the circuit before we go. On the back side here, this is our programming unit. This is our flash memory chip for saving data. That is our microprocessor, the the MSP 430. That's the 48-pin mount. This is our 4 megahertz resonator, which is powering the USB bus. This is our 32 kilohertz crystal oscillator, which is powering the internal clocks. This little N-channel FET is controlling this blinking light. That's just permanently telling it to go high for the time being in our software. These are our 2 switching apparatuses. This is our P-channel FET and N-channel FET, which drive the switching between our solar and our battery. The battery line, hard to see, is coming in between these 2 points right here, battery plus, battery minus. This is the main power bus on the circuit. A lot of it's going, as you can see, the width of this trace is getting smaller as it's delivering current to the various 7-segment displays. So that's pretty much all of the top of the circuit. I'll pull this out real quick just so you can see the underside of it in operation. There's our ground temperature sensor from before going into the ground. Our nickel metal hydrides providing 700 milliamp hours. That can always be increased if you want larger capacity. Here is our JTAG programming module. USB comes in through the side of the case to monitor, send information, send signals to the device to tell it how to operate, as well as pull data from it. And finally, these are the display drivers. You can see the pins on the 7-segment displays on the back. Everything else on this circuit is one more quick note as I'm thinking about it. That is our monitor LED that will blink every 15 seconds if we enabled that part in our software, which is currently disabled. Everything else is a passive component, either designed to, this is our input-output line. This is our display module right here. This is the power module up here. The control module is this little area right here. And this is the push button, which would control the 7 segments if the micro was currently enabled to handle that signal. That's kind of our quick overview showing our power module working during a sunny day. We're going to be demoing this inside, and hopefully it's not going to be raining outside. But worst case, there we go. And this is with it all unscrewed. Takes about a good 10 minutes to make sure this is all in this package. After we had this machined, note for the future, we were a bit off in specifying where we wanted the machine shop to put these mounting holes. This Molex connector is a bit too big, so it's a pretty tight squeeze with that Molex connector hitting that package right there. So that's kind of our overview for now. Thank you for watching. Our other partner, Tony DeRue, is not here right now, but he will be during demo day. Once again, this is Group 26 with the Growing Degree Day monitor. This